Often described as the most complex object in the known universe, the human brain hides our identities, our thoughts, our hopes, our dreams, and our aspirations. And even though we've made great strides at recording and probing from thousands of neurons, we're only at the very beginning to understand what those signals mean. Sometimes we have to look a little closer. We have to study a bit more carefully. This is the Coal-Sack Nebula, visible to the naked eye as a dark patch of nothingness in the otherwise brilliant southern sky. But if you look carefully, you will see not one, but millions of shining stars that were imperceptible just a moment ago. Research is like this Coal-Sack Nebula. Even if you think that everything has already been discovered and that there's nothing left to explore, there are thousands and millions of discoveries just waiting to happen if only you look a little bit more carefully, just like these millions of stars. But sometimes looking closer is not enough. Sometimes we have to look differently instead, and we need to find a way to find the hidden variables. I am a neuroscientist, and I study learning and memory. I'm working to uncover the hidden meaning of your thoughts and to understand how new memories are subconsciously filed away for longer-term storage. For this use, to study this, I use latent variable analysis. But what exactly is a hidden or latent variable, and what is latent variable analysis? Well, latent variable analysis is kind of like the dark web of the internet. It's like the cool uncle of data analysis, always with a trick up its sleeve. But simply put, a hidden or latent variable is simply a quantity of interest that we cannot observe directly, and we can only guess, or a little better, infer its value. Let's take a look at some examples. In medicine, if a patient presents him or herself with a set of symptoms, we may be interested to try and uncover the hidden or latent cause or the disease so that we can prescribe an effective treatment. Similarly, a psychologist might want to determine the degree of extroversion of a subject, or a social scientist might want to estimate a person's socioeconomic status or class. Oh, I skipped one. Let's move right along. Getting more technical, how about the set of actions that is guaranteed to lead to a positive response from my wife? Notice that the set of actions is time varying, but my wife certainly is not. Or the example of collaborative filtering, popularized by the Netflix challenge a few years ago, where we are interested in learning a set of latent or hidden factors that people enjoy in a set of movies, and then we want to use those hidden factors to try and predict which other movies they are likely to enjoy. One of my personal favorites is the task of manifold learning, a form of nonlinear dimensionality reduction. Here you see a manifold representation of a man's face, and interpolating from one end of the manifold to the next corresponds to an increase in facial hair. For my own work, I use hidden Markov models. And I use hidden Markov models to uncover patterns of neural activity that repeat over and over again at a compressed timescale. I believe that these so-called replay events play a central role in memory consolidation. And using latent variable analysis, I'm able to peek inside to not only uncover the mechanisms, but also the hidden meaning of these events. Sometimes incredible insights really are hiding there in plain sight. So keep on peering deeper into the coal sack. Keep on chasing those discoveries. Open yourself to new perspectives and never stop learning. Find a fresh way to look at your research problem, and next year, come and share with us what your data is hiding.